The Wonders of Light, Part 1. We would learn about 1. Images formed by convex lens. 2. Functioning of lens in human beings. 3. Problem of vision and their remedies. And 4. Application of spherical mirrors and lenses. Hello kids! Images formed by convex lens. As per ray diagram, we are studying about position, nature and size of the images formed by lenses. So kids, the rules of images formed by convex lenses are as follows. Rule number 1. If the incident ray is parallel to principal axis, then the reflected ray passes through focus F. Rule number 2. If the incident ray passes through optical center, then the optical center undeviated. Rule number 3. If the incident ray is passing through the focus, the reflected ray passes parallel to the principal axis. Now we are understand the ray diagram of the image formed in the convex lens for different position of an object are. When object is placed at the infinity position, then image is formed at focus F2. The size of the image is highly diminished or point size. The nature of image is real and inverted. When object is placed at beyond point 2f1, then image is formed behind the lens in between point f2 and 2f2 in downward direction. The size of the image is diminished. The nature of image is real and inverted. When object is placed at point 2f1, then image is formed behind the lens in downward direction at beyond the point 2f2. The size of image is same as object. The nature of image is real and inverted. When object is placed in between point f1 and 2f1, then image is formed beyond the point 2f2. The size of the image is magnified. The nature of the image is real and inverted. When object is placed at point f1, then image is formed at infinity. The size of the image is infinitely large and highly magnified. The nature of the image is real and inverted. When object is placed in between origin O and point f1, then image is formed beyond the point 2f1. The size of the image is magnified. The nature of the image is virtual and erect. Now let us learn about sign convention for lens. Focal length of convex lens is positive and that of concave lens is negative. Optical center of lens is taken as origin and principal axis of the lens is taken as x-axis. The sign convention for lens is similar to the sign convention of spherical mirror. Lens formula. The relationship between the object distance u, image distance v and focal length f is lens formula. The lens formula is given as follows. 1 upon v minus 1 upon u is equal to 1 upon f. Magnification by the lens. It is ratio of height of the image h2 and height of the object h1. Magnification produced by lens also related to object distance u and image distance v. The relationship is given as magnification is equal to distance of the image upon distance of the object. That is, m is equal to v upon u. What is power of lens P? It is the reciprocal of the focal length. The unit of power of lens is diopter. Functioning of lens in human beings. The human eye has a thin membrane called cornea. The light enters the eye through the cornea. Behind the cornea, there is the dark muscular diaphragm called as iris. There is small opening of variable diameter at the center of iris called pupil. The eyeball is spherical in shape with the diameter of about 2.3 cm. There is transparent biconvex crystalline body located just behind the pupil called lens. The focal length of eye lens increases while viewing the infinite distance objects and lens becomes thin. The focal length of the eye lens decreases while viewing the nearer objects and the lens becomes thick. Problem of vision and their remedies. The problem of vision are of different types, having different reasons. For example, change in size of eyeball, weakening of ciliary muscles, irregularities on the surface of cornea. Myopia or nearsightedness. It is the defect in which human eye able to see nearby objects distinctly but not so clearly. Hypermetropia or long-sightedness. It is the defect in which human eye able to see distant object but unable to see nearby objects clearly. Presbyopia. It is also called as old age hypermetropia. Sometimes old age person suffers from both myopia and hypermetropia. In such case, use bifocal lens for correct the defects. Bifocal lens consists of upper part is of concave lens and lower part is of convex lens. concave lens is useful to correct defect of myopia and convex lens is useful for correct the defect of hypermetropia. Let we study about application or uses of spherical mirrors and lenses. A. Concave mirror. 1. In torches and headlights, the source of light is placed at the focus to obtain the parallel beam of light. Two. In floodlights, the source of light is placed just beyond the center of curvature to get intense beam of light. B. Convex lens. 1. Telescopes. A combination of two convex lens is used in telescope. 2. Spectacles. Convex lens is used in spectacles to correct the defect like hypermetropia. Summary. The defect in human eye can be corrected with the help of lenses. 2. Two types of lens. Concave lens, which is used for correct the defect, not to see the nearby image, and convex lens is used for correct the defect, not to see the distinct image. 3. Myopia is the defect in which human eye able to see the nearby image clearly, but not distant image. 4. Hypermetropia is the defect in which human eye able to see the distinct image but not nearby. Five. Concave mirror is used in torch, floodlights, projector lamps, solar furnaces, etc. 6. Convex lens is used in microscope, telescope, camera, spectrometers, etc. That's all in this lesson. Learning is fun, so keep learning, students.